Good morning, everyone. Welcome back. Thank you for joining us. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, the Science and Technology channel.
Yep, and we hope you are enjoying your holiday season. And
Yes, sir.
you got through Christmas okay, and everything's plugging along, and we're approaching the new year. So,
Yes, sir.
yep, and we're still talking science and technology. That's what we do.
Yep. Using Georgia State's CHARA array, that's an acronym spelled CHARA, array, an international team of scientists has uncovered unexpected complexity in how stars explode. Astronomers have obtained images of two stellar explosions called novae just days after they erupted, capturing them in detail never achieved before. And on your screen, you can see a blow up of one of the details, and you'll see it a little bit later on another slide, too. These observations show directly that novae are far more complex than scientists once believed, involving multiple streams of expelled material and, in some cases, long delays before that material is released. This international study was published in the journal Nature Astronomy on December 5th, 2025. Would you like to know more?
The research relied on a powerful observing method known as interferometry at the Center of High Angular Resolution Astronomy, which is a CHARA array in California. By combining light from several telescopes, researchers achieved the extremely fine resolution needed to image these fast-changing events as they unfolded. Quote, the images give us a close-up view of how material is ejected away from the star during the explosion, says Georgia State's Gail Schaefer, who is the director of the CHARA array. Going on with the quote, catching these transient events requires flexibility to adapt our nighttime schedule as new targets of opportunity are discovered, unquote.
Okay, let me advance the slide here.
That's
Okay.
That's an interesting looking object.
Yeah, that they captured it. It's pretty cool. So on the screen, you can see, you can go ahead and pause and read the caption. It's showing the far away, and then a little bit more close up, then a really close up. I wonder if that's artistic impression. Okay. On your screen now, scientists at Georgia State CHARA array captured images of nova V1674 Hercules, one of the fastest stellar explosions on record. Images of nova V1674 Hercules obtained 2.2 days and 3.2 days. That's the middle. The 2.2 is on the left. So it takes a while for this explosion. After the explosion, the images reveal the formation of two distinct perpendicular outflows of gas, as highlighted by the green arrows. The panel on the right shows an artistic impression of the explosion.
Novae happened when a compact stellar remnant called a white dwarf triggers a runaway nuclear reaction after pulling material from a nearby companion star. Until recently, astronomers had to rely on indirect clues to study the earliest phases of these eruptions because the expanding debris appeared only as a single point of light. Okay.
Understanding how this expelled material is launched and how different flows collide is key to explaining how shock waves form in novae. Such shocks were first revealed by NASA's Fermi Large Area Telescope, LAT, over its first 15 years. Fermi LAT detected GeV gamma ray emission from more than 20 novae, confirming that these explosions can produce high-energy radiation and making them important targets for multi-messenger astronomy.
The researchers focused on two very different novae that erupted in 2021. The first, Nova V1674 Hercules, was one of the fastest ever observed, rising and fading over just a few days. Images showed two separate streams of gas flowing in perpendicular directions, indicating that the explosion involved multiple interacting outbursts. Notably, these structures appeared at the same time that NASA's Fermi Gamma Ray Space Telescope detected gamma rays directly linking the high energy emission to collisions between the outflows. This is almost like the tree that falls in the forest, right? Does it make a noise, or
Yeah.
does,
Does anybody notice it?
yeah, does anybody notice it if there's nobody around? I don't know. Kind of weird.
Okay, the CHARA array on your screen now, and this is like a rendition, not a photograph, is located. We'll have a photograph on the next slide. Is located at the Mount Wilson Observatory in the San Gabriel Mountains of Southern California. The 6 telescopes of the CHARA array are arranged along 3 arms. The light from each telescope is transported through vacuum pipes to the central beam combining lab.
The second object, Nova V1405 Cassiopeia, behaved in a very different way. There's a what do you call that? Astronomy stuff. What do you call that when there's an array of stars? What do you call that?
Well, a constellation.
Constellation. Yeah, there's a constellation called Cassiopeia's CHARA.
Yep.
Anyway, it evolved much more slowly and unexpectedly, retained its outer layers for more than 50 days before releasing them. This observation provides the clearest evidence yet that some novae delay the expulsion of material. When the gas was finally ejected, new shock waves formed, once again producing gamma rays observed by NASA's Fermi telescope.
Quote, these observations allow us to watch a stellar explosion in real time, something that is very complicated and has long been thought to be extremely challenging, said Elias Eide, lead author of the study and professor of physics and astronomy at Texas Tech University. Continuing the quote, instead of seeing just a simple flash of light, we're now uncovering the true complexity of how these explosions unfold. It's like going from a grainy black and white photo to high-def video.
So again, we're all over the place on these with these scientists, right?
Yeah.
Texas Tech, California, cool. The ability to resolve these such fine detail comes from the use of interferometry, the same technique that made it possible to image the black hole at the center of our galaxy. These sharp images were further complemented by spectra from major observatories such as Gemini, which track the evolving fingerprints of the ejected gas. As new features appeared in the spectra, they lined up with the structures revealed in the interferometric images, providing a powerful one-to-one confirmation of how the flows were shaping and colliding.
Yeah, that's interesting. So here's like the drawing. This next slide is the actual aerial photo.
Yeah, that's Mount Wilson.
San Gabriel, yeah.
Yeah, it's just right, not too far from here.
Yeah. So here you can clearly see the buildings, but here you can see it's wooded and dense. It's pretty neat. On your screen now,
you can see in the background the evidence of some of our infamous fires that we have here in the San Gabriel and San Bernardino Mountains, and how they really work to save the Mount Wilson Observatory. It's a famous observatory. So anyway,
on your screen now, the circles mark the domes of the 6 CHARA array telescopes at the historic Mount Wilson Observatory. Quote, this is an extraordinary leap forward, said John Monair, professor of astronomy at the University of Michigan, go Wolverines, a co-author of the study and an expert in interferometric imaging. The fact that we can now watch stars explode and immediately see the structure of the material being blasted into space is remarkable. It opens a new window into some of the most dramatic events in the universe.
The results not only reveal unexpected complexity in novae, but also help explain their powerful shock waves, which are known to produce high-energy radiation such as gamma rays. NASA's Fermi telescope has been the key instrument in discovering this connection, establishing novae as natural laboratories for studying shock physics and particle acceleration.
Quote, novae are more than fireworks in our galaxy. They are laboratories for extreme physics, said Professor Laura Chomiak, a co-author from Michigan State University. Wow, Michigan and Michigan State working together. That's weird. And an expert on stellar explosions. Continuing her quote, by seeing how and when the material is ejected, we can finally connect the dots between the nuclear reactions on the star's surface. the geometry of the ejected material, and the high energy radiation we detect from space.
Well, yeah, so one more player there, huh? Michigan
Yep.
State. The findings challenge the long-held view that nova eruptions are single, impulsive events. Instead, they point to a variety of ejection pathways, including multiple outflows and delayed envelope release, reshaping our understanding of these cosmic blasts.
Quote, this is just the beginning, ID said. With more observations like these, we can finally start answering big questions about how stars live, die, and affect their surroundings. Novae, once seen as simple explosions, are turning out to be much richer and more fascinating than we imagined. Pretty
Mm,
cool.
yeah. Yep. And the fact that of all in all the years that Mount Wilson has been there, that observatory has been there, it's still a key player in watching this stuff. I think that's really cool because I think NASA obviously is involved in this. I'm sure Caltech is. I know Jet Propulsion Laboratory uses some of the stuff from Mount Wilson as well as other Deep Space Network sites around the globe. One here basically in our backyard, not too far from Barstow, about 40 miles, 35, 40 miles from Barstow. So, yeah, this is cool stuff. Very cool.
All right, folks. Thanks for joining us. We'll catch you tomorrow.
Okay, take care, everyone. Thanks.